Hello everyone. Welcome to Module 9 of our Software Design and Development course. We have covered design, front-end, back-end, testing, and deployment. Now it is time to bring everything together. This module is about building real-world software applications, not just isolated features, but complete systems like accounting software, ERP platforms, and learning management systems. This is where you transform from a feature developer into a solution architect. In today's module, we will cover the following: step-by-step methodology for building accounting software, modular architecture for enterprise resource planning, ERP systems, designing and deploying learning management systems, engineering complex distributed software systems, seamless integration of UI/UX, back-end, database, and security, a practical project development workshop, and finally, cross-functional workflows and technical debt management. Let's dive in. Modules 1 through 8 give you component-level skills, front-end, back-end, APIs, databases, testing, and DevOps. But professional software engineering is measured by your ability to synthesize these disciplines into cohesive production-ready systems that solve real business problems, serve diverse user roles, and scale under operational demand. Whether you are designing an accounting platform with strict financial regulations, an ERP unifying supply chain and HR workflows, or an LMS delivering education, under demand. Full system integration is what separates feature developers from solution architects. Accounting software demands precision, compliance, and financial integrity. Core domain requirements for an accounting software include double entry bookkeeping, general ledger, accounts payable and receivable, tax calculation, and audit trails compliance with GAAP or IFRS. Database example, enforcing the accounting equation using SQL. Best practices here include use numeric, not float, for currency. Implement in idempotent endpoints, transaction rollback on any failure. Role-based access control for auditors. Financial data cannot tolerate errors. Your design must be blueproof. Developing ERP systems. An ERP system unifies multiple business functions into a single platform. Core modules are finance and accounting, human resources, supply chain and inventory, customer relationship management, CRM, and procurement. The integration points are API gateway for routing and centralized authentication, event-driven communication for cross-module consistency, strict foreign keys where needed, eventual consistency where appropriate. Architecture choice include modular monolith, which is good for mid-sized organizations, or microservices for enterprise scale but add complexity. The goal is the modules to work together without becoming a tangled mess. building a learning management system. And LMS delivers content, track progress, and enables communication. The core components here are multi-role authentication for students, instructors, admins, and TAs. CND-based media delivery, assessment engine for quizzes, auto-grading, and rubrics. Real-time features for forums, chat, and notification. Progress tracking example in the act. The compliance requirements are GDPR for student data privacy, WCAG 2.1 accessibility standard, and course level data isolation. An LMS must be accessible, scalable, and privacy compliant. Real-world systems often require advanced architectural patterns. Event-driven architecture as services communicate via events, doubles components, and improve resilience. Command query responsibility segregation, separate read and write models for optimized performance. Event sourcing stores state changes as immutable events, streams, complete auditability, and abilities to rebuild state. Saga pattern manages distributed transactions across services using compensating actions. To mitigate challenges, distributed data consistency, network latency, and failures are monitoring and tracing complexity. These patterns are powerful but add complexity. Use them when the problem demands it. Integration is where most projects fail. Contract-driven development prevents that. Standardized API error response example. And the integration workflow is shown as this. The layer practices for UI to backend is open API contract, optimistic UI with rollback standardized error format, while backend and DB, repository pattern, connection rolling, N+1 prevention, and migration versioning. For security, CSP headers, XSS sensitization, parameterized queries, TLS 1.3, and WAP. Cross-layer cohesion ensures no single component comes a weak link. Now it is time to apply everything to your capstone mini project. The scenario here is architect a production-ready prototype, choose from accounting dashboard, ERP module, e.g. inventory management, learning management system, cost enrollment flow. The deliverables expected are system architecture diagram and tech stack justification, normalized ER diagram with constraints and indexes, often API specifications for 3 core endpoints, 1 complete user flow, RBAC input validation, error for error handling, 5-unit integration test, CI/CD pipeline configuration for auto test on push. Architectural integration, security, maintainability are not feature block. This is your opportunity to demonstrate end-to-end engineering competence. In engineering disciplines separate successful enterprise system from failing ones. The best practices for development and collaboration are front-based development or Git flow matching release cadence, PR templates, automate linting mandatory reviewer approvals, living ADRs, architecture decision record, API docs, and onboarding guide. For quality and maintainability, allocate 15 to 20% sprint capacity for each depth and refactoring. Future flags over long light breaches, merge early, disable unit ready. Observability from day one, structured logs, metrics, alert thresholds. For business alignment, cost-aware architecture, Compliance by design, user-centric releases are the best practices. Great engineering is not just about code, it is about outcomes. Let's look at a quick checklist on do's and don'ts for real-world deployment. For the do's, enforce API contract before coding. Implement in idempotency keys for financial transactional endpoints. Use database transactions for multi-table operations. Conduct load testing before scaling infrastructure. Document architecture decisions and rollback procedures. For the don'ts, do not bypass input validation, assuming front-end handles it. Do not use select with asterisk or unindexed queries in production. Do not hardcode business rules or environment-specific configurations. Do not merge untested breaches directly to men. And lastly, do not ignore compliance requirements until you go live. This habit protect your system and your career. In conclusion, today we covered real-world software application engineering, such as accounting software for precision, compliance, financial integrity, ERP systems, which are modular architecture for enterprise workflows, learning management system for content delivery and progress tracking. We also talk on hands-on workshop to demonstrate end-to-end competence, and we talk of the best practices for large-scale application. This prepares you for module 10 and the final module, career development, professional certifications, portfolio building, and your capstone project delivery. Let's get there.